Okay, boys, we are moving towards the second lecture of May June 2024, and paper version is 41. Before this, if you have not understand the first lecture of IGCSE, and you will see the right on the right corner I button. You have to click on that button, then you can easily find out the whole playlist. Okay, now moving, we in first lecture I have solved almost 3 questions in detail. Now we are moving towards the question number 4, that is related to the chapter light. So look at that. The lens in the magnifying glass is a converging lens. This is the converging lens. Okay, question number A is figure 4.1 shows the lens of the magnifying glass. Its two focal points f1 and f2, and its principal axis has been shown. Okay, the line that is passing from the focal length and the center of the lens is called principal axis, and the point that is mentioned here, f1 and f2, these are called focal point, because when the light, I will explain it later. Check out the question what he has asked, what is meant by focal length. Okay, to understand the focal length, that is f1 and f2, I will explain right now on the whiteboard also, and look at that. Okay, so remember, when you place an object on the principal axis in front of a lens, suppose this is your uh, object. Okay, the lines coming out from the object moves parallel to the principal axis, and then when they hits the lens, after that they are converged towards the focal length, focal point. Okay, this is the point. So you have to define it just like that. Move towards the question. What you have to write here, you have to define what I have shown you. The line, the rays coming from the object moves parallel to the principal axis and hits the lens. After that, after hitting the lens, the rays converge towards the focal point. Okay, towards the point that is called focal point on the principal axis. This point is called focal point. Is it clear? Okay, converge, right here, converge towards the principal axis, that point is called. Okay, you will get easily 2 marks here. Now question number 2 is, a student using the magnifying glass sees a magnified image of an object. On figure 4.1, mark a point X on the principal axis for the possible position of the object, and second is the point E for the possible position of the student I. So there are 6 cases you have to understand. I will show, these are the 6 cases of the image formed by the converging lens. These position are related to the position of the object. When position of the object changes, as a result the image position and image size also change. Okay, but the question that is related above is, if you look on the question, it has mentioned a point X, and one thing more, it has written here magnifying glass sees a magnified image. So this is your question. So in that case you have to find out the position of the object from these 6 cases. So you will get here, this is the position, this is your case when the image formed by the lens is magnified and upright. Okay, so in that case you will see here, this is the center O of the lens, and the principal of first focal length f1 is here. The position of the object is AB. Okay, when the object is placed between the focal length and the lens, then object image formed is will be upright and magnified. So this is your case. So you have to write here X, as you will see in the question, and observer will see the image of that object from this position. Is it clear? So move towards the question. I will write here position. Okay, so I will write here, you have to place the object on this position, and image you will see here like this one. This is the position where you can see, where observer can see the image. If you look on the whiteboard, uh, I will move towards it. Yes, this is, I will write for your understanding. I will remove all these things. This is your position of the image. Rays parallel to the principal axis will move towards the lens, and then it is converged towards the focal point, and second rays that will pass from the center, uh, just like that. If you move these lines backward direction, they will meet at certain position here. Okay, you can see they are moving at that position. Okay, so you will get the position of the image just like that. So this is your image I, and this is your object, and this is your position of your eyesight. Is it clear now? I have explained the whole things that is asked by the examiner. Okay, now what is that? Underline the two words in the list that describe the image form produced in this one. So if you look uh, on this one, the image that is formed, it is on the same side as the object here. Okay, so image is vertically upright, and the size of the image is greater than the size of the object. So this is magnified object and upright. So you have to find out two here. First one is upright and second one is virtual. I will explain it just like that. The image formed on the screen is called real image. The image that is not formed on the screen is is called virtual image. So in that case, when you are talking about the magnified image that you have made the ray diagram, that is virtual, because there is no screen behind the object and it is vertically upright. The real, this is not real image, this is not inverted. Okay, now question number B. The refractive index of the glass used to make the lens is 1.5. This is the refractive index. The speed of light in the air is this one. Calculate the speed of light in the glass. So we will solve it in the word file. Yes, this is your question solution. The formula of refractive index is N is equal to speed of light in air divided by speed of light in medium. So speed of light is represented by c, and speed of light in the medium is represented by v. So you have to find the v. You have to replace v with the n. You will get c by n. The value of c is 3 into 10 raised to the power 8, and the value of refractive index in the question it has given to you 1.5. When 3 divided by 1.5, you will get 2. This will remain same. So your speed of light in the medium is 2 into 10 raised to the power 8 meter per second. So it is very easy question. So move towards the next question. State what happens to the wavelength of the light as it passes into the lens. I will give you the hint here. Again moves towards the question. The speed of light in the air is always the same. It is constant value. This is its maximum value. When the speed of when the light moves towards enters into the glass, then wavelength of the light decreases. I will write here rho c, and here will be, this is your wavelength decreases. As a result, speed also decreases, but your frequency will remain same. Okay, so you will write here what happens to the wavelength when light enters into the lens or glass, because lens is made up of glass, its speed decrease. Is wavelength decrease, as a result speed also decrease. Its wavelength decreases, as a result its speed also decreases. Okay, this is your complete answer. Converging lenses are used in spectacles glasses to correct one problem with vision. Okay, this is related to the eyesight. Okay, state the name of the problem that explain how a converging lens is used to correct it. You may draw a diagram, name of the problem. Remember, converging lens is mostly used for long sightedness. In long sightedness mean you can see the far distant object easily, and but you cannot see the nearby object. Nearby object will be blurry for you, and distant object will be clear. Okay, this disease can be covered by using converging lens. I will show you how this can be managed. Okay, this is your diagram here. If you look on that, the person that has long sightedness, this is the image of short sightedness. I will show on next diagram long sightedness. Just wait. Yes, this is the just wait. Yes, this is your. Okay, look on that diagram. In long sightedness, the image is not formed on the retina. Okay, retina, but image is formed behind the retina. That is why you cannot see the nearby object. Nearby object are those that is at 25 centimeter from your eyes. Okay, but when you use a converging lens, then this image will be converted into the retina due to the converging lens. So in this way, this long sightedness disease can be covered up. If you look on one more thing, if you look on the short-sighted nets, in short-sighted nets we use diverging lens, that is concave lens. In short-sighted nets, uh, you can see nearby object clear, but distant object will be blurry in your eye. Okay, in that case your image is formed in front of the retina. Okay, but when you wear your glasses that is made up of concave lens, then image will form on retina. But your case in the question is long sighted nets, so you have to draw this diagram behind this, and you also explain this which I have told you. Okay, now question number 5 is, describe how a longitudinal wave differ from a transfer wave. So it is very easiest chapter of physics of IGCSE. I will write here, in transfer waves, particle of medium moves perpendicularly perpendicular I will expand stature. Okay, perpendicular to the direction of propagation of wave, but in longitudinal wave particles move parallel to the direction of propagation of wave. One difference is this, and second difference, you can write uh, transfer waves. The example of transverse waves is water wave, and the example of longitudinal wave is you can see the sound waves. In transfer waves, particles move side by side, and in longitudinal wave they are moved backward and forward. The second difference is this one. And transverse waves, remember, some transfer wave needs a medium, but in longitudinal wave sometimes we don't need a medium. It depends upon the situation, because electromagnetic waves are longitudinal waves, they do not require medium for its propagation, but in case of sound wave they require medium for its propagation rate. So it depends upon the situation what is that. So moves towards question second part. 5 point figure 5.1 represents a seismic waves produced by an earthquake. Okay, this is the longitudinal pattern. Okay, state what is the whether this seismic wave is a P waves or an S wave. Justify your answer. Remember, look at this one. The primary waves are longitudinal waves. It generated first during earthquake, and secondary waves are produced after the primary wave. Okay, and primary waves are little bit faster than the secondary one, so secondary waves are slower. Okay, these are longitudinal in nature and these are transferred in nature. So you have to write it in a very smart way. uh, First point you will write here, the above diagram is primary waves. They are because these are longitudinal wave and moves faster. as compared to secondary wave. Longi, this is your primary waves. Okay, you get easily 1 marks. Next is the wave represented in the figure has wavelength of 1.2 10 raised to the power 4 meter. Calculate the actual distance between point J and point K. So one thing more, in in longitudinal wave there are you can see here some lines that are far apart. This region is called compression, and the region where lines are very close to each other, this is called this is called compression. Where far apart, this is called rarefaction. I will write here, this part is compression, and this part is rarefaction. Okay, this also rarefaction. Okay, the distance between two consecutive compression and rarefaction is called, or rarefaction is called wavelength. I will write here also compression. Okay, look this one. From this J to this one you will get one wavelength, and then from this point to this point you will get half wavelength, because the distance between one compression and consecutive rarefaction is half of the wavelength. You will write here half of the wavelength, and this is your complete wavelength. Okay, so when you will add them, you will get 1.5 of wavelength. So what you have to do now, 1.5 multiply by the value given in the question. I will solve it in front of you. This is your wavelength. I have already write here 1.5 multiplied by the value of wavelength is 1.2 into 10 raised to the power 4. This is given, so you have to multiply this, you will get easily answer. Okay, you will get 1.5 multiplied by this one, 4, 18,000. Your answer will be 18,000 meter distance. Okay, next is the wave in 2 travels through a ground at a speed. This is speed of the wave by which it is traveling through the ground is 4600 meter per second. As the wave passes a certain point, the ground completes 5 oscillation. It means number of 5 oscillation mean 5 wavelength, 5 completed wavelength. Calculate the time that it takes for the wave to pass. Show your working. It is very difficult question, but I will solve it. I have solved already this. Look at that. You have to apply the formula V is equal to F lambda, and here F is the frequency is known as the reciprocal of time period, so you have to replace F with 1 by T. In question it has mentioned that 5 oscillation. If you look on the question, the ground completes 5 oscillation. Okay, so you must place T with T by 5. Okay, this 5 will be multiplied by lambda. Here you will get 5 lambda by T, and you have to find the speed. T is interchanged with the V. You will get T is equal to 5 lambda by V. Write down the value 5 multiplied by wavelength is, and speed is given 4600. You will get 13 seconds. This is the time when 5 oscillation is passed through the ground, but we need the time of 1 oscillation, so you must divide 13 with 5, you will get 2.6 second. It means in 2.6 second your one wave is passed through the ground. Okay, so your answer will be 2.6 here. I will write here. Next, last question, and in third lecture I will solve 7 to 8, then paper will be ended. In figure 6.1 shows an isolated metal sphere suspended by an insulating thread from the ceiling. This is your ceiling, this is insulating thread, and this is metallic sphere. The sphere is negatively charged. Okay, it means, I think it was easy. It is easy question. The charge on the sphere produce an electrical field in the surrounding. What is meant by electric field? Electric field mean the region are spaced around the charge in which it exerts a force on another charge. It will exert a force on another charge. I will explain on the board here. Suppose that this is your charge, okay, and this is the region around the charge. When any external charge from outside come into the field, then this charge will exert a force on that charge. As a result, that point charge will move out from the field. So this area and this space is called electric field of that charge. Drawn figure to show the pattern and direction of the electric field produced by the charge on the sphere. Draw at least 4 lines. Okay, remember remember one thing: the electric field lines during electric field lines due to the negative charge is vertically outward, and in case of positive charge the direction of electric field lines is vertically outward, but in case of negative charge it is vertically inward. So I will draw it on. Okay, right here you have to write. Okay, this it will be vertically outward here from this position to this one. I will write here multiple. You have not to draw lines inside because the charge are available on external side, not inside. Okay, from this one it is vertically here. From this position you will get it like that. Okay, in the same way electric field lines will be from here, and from this position to this one, from this position to this one, and from this position to this one. And now you have to draw the direction. This is your direction, inward direction. Then you will get 2 marks. I think this question is 2 marks. First one you have to write down the lines, and second marks when you will show the direction by using arrowhead. Okay, this is short answer. Next is the magnitude of the charge on the sphere is this one. That the quantity of the charge that is available on the surface of the sphere is this, and metal wire is touched against the surface of the sphere and the sphere is discharged. Here what happens to the wire as the sphere is discharged? Again moves towards the whiteboard. Suppose it has mentioned that suppose you are touch suppose this negative charge is available on the surface of the sphere. When you attach earth wire with the sphere, what happened? Remember, suppose this is your earth wire with the ground. It means it is connected with the earth. In earth, positive and negative charge always available. When you touch the earth wire with the sphere, then these negative charge will start to move through this wire towards the ground. As a result, uh, this charge will, the sphere will be completely discharged. So you have to write here what happens to okay, charge, negative charge, you have to write negative charge. Negative charge will move towards the earth with the help of earth wire. Is it clear? Okay. As a result, your sphere will be discharged. Now it takes a time of 0.14 nanosecond for sphere to discharge completely. Calculate the average current. It means the available negative charge is moved towards the earth with the help of earth wire in 0.14 nanosecond. Then how much current is available in the wire? So you have to apply the formula of current. I is equal to rate of flow of charges Q by T. The charge is given and value of current is value of time is 0.14 nano. You have to place the value of nano 10 raised to the power minus nano, and then you will divide these two terms, you will get 2.5 ampere. It means 2.5 ampere current will pass through the earth wire. So I will write here 2.5 2.5 ampere. Ampere is the unit of current. Okay. Now I'm going to end this today lecture. Last three question will be attempt in lecture number 3. So keep in touch. Goodbye.